Space industry is not only expanding, it's also converging with the telecom industry, and therefore there's going to be a lot of demand for people with telecom experience. If you go to Starlink career page or Amazon Leo career page, you will see a lot of these telecom RF related openings which are there on their website. In this video, I'm going to walk through exactly why, what is happening, what kind of telecom skills can map into what space industry is looking for, and how long the transition can actually take, and what you need to do in next 90 days if you want to make this move. This is the Orbital Shift, the career playbook for transitioning from telecom to space. And before you click away thinking this is some kind of abstract future of a work video, it is not. It is happening right now in 2026 with real hiring, real job postings, and real money on the table. The space industry is short on engineers, not the way you think. There are plenty of aerospace engineers. What they don't have is the people who understands how to run a carrier grade network, like 5 nines uptime, spectrum coordination, 24/7 operations, wholesale deals, and subscriber billing. That is not an aerospace skill. It's a telecom skill. That is your skill. And quick roadmap for what we will be covering, why this convergence is happening, where telecom and space technically is overlapping, converging, the actual roles being hired for, the skill gaps you need to close, realistic transition timelines, and where the world is hiring happening for these roles. By the end of this video, you will know exactly where you would slot in. Here's a mindset shift you need to make before anything clicks. For 30 years, telecom whole job has been solving one problem. How do you get to a signal from point A to point B in a more reliable way at scale for millions of subscribers? You solve that on the ground with the telecom experience, tower, fiber, spectrum, core networks. Today, that exact same problem is in a different shape. Signal from point A to point B, we have to be reliable at scale, is being solved 500 to 36,000 kilometers above the Earth in the orbit. Same problem, different altitude. That's a whole reframe. You need to become like an aerospace engineer to work in space. You need to apply your mastery, which you already have, link budgets, network operations, spectrum management, to a new medium. Space isn't replacing telecom. It is becoming telecom's next extension. Just like 5G became extension of 4G, the same way fixed broadband become extended into mobile. I want you to sit for that, use that for a second, because a lot of telecom professionals, they just self-elect out of this opportunity thinking, hey, I don't understand space. I'm not a space person. You don't need to be. You need to be a connectivity person who is willing to learn a new physical layer. That's it. So why is this happening right now specifically? Let's look at it. What's the actual engine behind? Talk about the market size, which is growing, as you can see on the left side. Both global 5G NTN market as well as direct to device is compounding 31% CAGR growth, for example, and this is a huge market opening up for direct to device, like $26 billion by 2034. Now within that, direct to device is a big growing segment. Now here's the part you should know personally. Look at this seesaw on the right side. This is where the most interesting piece is. On one side, you've got space native graduates, people coming out of aerospace engineering, low supply. On the other side, you've got NTN hiring demand. It's high, it's climbing very fast. The telecom talent pool is balancing the seesaw, not the aerospace, and which is you if you've got telecom experience. And here's the line that I think explains this better than statistics. It is definitely, it is infinitely faster to teach a RF expert orbital mechanics than to teach an aerospace graduate about building a scale carrier grade networks from scratch. So which telecom skills map to which space skills which is needed? So let's get some concrete discussion in place. A lot of things on this slide. So 4 areas I will focus on. Top left, technical and architecture. 3GPP is the same standards that define every generation of the mobile network, 4G, 5G, which is now being built satellite support directly into 5G standard itself. It's called NTN, non-terrestrial networks, and it landed in 3GPP release 17 and 18. On top of that, direct to device service is now live, meaning you have a very regular smartphone which can latch onto a satellite, and if you're hiking it can still connect. You can make calls, you can do SMS, etc. No special hardware. That satellites themselves are running cloud native 5G core on board, doing what's called regenerative payload processing, actual network processing happening in the orbit. The top right is standards consolidation. The GSM and ITU, the two bodies that have historically governed mobile and satellite separately, are now merging their rule books. 3GPP is now governing satellite access nodes the same exact way it is governing the terrestrial cell tower. So that's not a minor detail. That's how the industry is owning the standards body, saying these are the same things now. The bottom right is spectrum sharing. There's a framework called Supplemental Coverage from Space, SCS, that's breaking down the historical wall between terrestrial mobile spectrum and mobile satellite service spectrum. Satellite operators can now use a mobile network's own licensed spectrum to deliver coverage. That used to be functionally impossible from a regulatory point of view. Now it's a standard deal structure. The bottom left is commercial convergence, and this is the one you're probably actually seen in the news. So mobile network operators partnering, like T-Mobile is partnering with Starlink, AST is partnering with Vodafone, and so forth. These deals are structured almost exactly like virtual network operator MVNO deals or international roaming deals. And this has been going for decades, nothing new. The commercial playbook isn't new. It's just pointed at a new partner. So 4 things, one direction. Telecom and space are becoming one technical and regulatory framework, and that convergence is creating a very specific, very measurable talent gap. This is a table you have wanted to screenshot, honestly. This is your cheat sheet. Down the left, you see telecom domain. In the middle, the space equivalent. In the right, you see how strong the transfer skill is. So let's go through the very high tier first. Now, these are very closest to plug and play. RF and antenna engineering maps to SATCOM and payload RF. Very high transfer. The physics of link budget doesn't change. Only distance and Doppler effects do. Spectrum and regulatory works map to satellite spectrum coordination. Also very high. If you filed for interference coordination with an international regulator, you know how to file. You already understand 80% of orbital coordination requirements. IoT and MTM engineering maps to satellite IoT. Think narrowband IoT over NTN. Very high transfer, since the whole point of NB IoT was always low power, wide area, and fast connectivity. This is basically what satellite is also enabling. Then comes the high tier core network 5GC, mapped to NTN core and ground core. Network operations, if you have got NOC experience, mapped to ground segment operations. Systems and test engineering maps to systems integration. Cybersecurity maps to space and satellite cybersecurity. Business development maps to space and BDN partnerships. So let's look at some medium, high to medium. Product management maps to space connectivity product roles, and program management maps to space mission management. Viable, just that you have to have a little longer runway to map the skills and reskill yourself. Here's a line which I want you to actually remember from this whole video. Your core expertise isn't being reinvented in orbit, it's being reapplied. The physics are identical, only the geometry is changing. Now let's get even more specific, because high transfer is nice, but you need to know how long it actually takes, what the translations sound like in the practice. So there are 5 specific technical roles, and it shows the actual mechanics of the transition. So let's say RF and radio engineer to SATCOM engineer. The core translation is you're adopting link budgets, modulation scheme, Doppler effects, since satellites, especially in the low orbits, are moving very fast related to the Earth, reference speed of the ground receiver. So it will take like 4 to 9 months to kind of do that transfer of the skill. 5G core or RAN architect to NTN system architects. You're integrating satellite access nodes to 3GPP release 1718 hybrid architectures, basically treating the satellite as another radio access technology talking to the same core. Timeline could be 6 to 12 months. You could look at the role and the skills required. NOC or the network operations to ground segment operations. You're applying this exact same 24/7 SLA, discipline, incident management, etc., which you run, just pointed at teleporting and TTNC gateways instead of cell sites. Timelines could be 3 to 6 months to learn this, and this is one of the fastest transition because it's more about discipline here. Telecom security to cyber security, you're pivoting from a security signal protocols, which is SS7, to basically hardening your TT&C uplinks and direct-to-device signaling. 4 to 8 months is what it should take. Systems or test engineering is where you're mapping into space integration engineer. You're validating end-to-end interoperability across terrestrial, ground, and space segments, multi-vendor testing, and if you're working telecom, you have absolutely done that before. Just the third domain is added. So maybe 5 to 10 months, you should be all up and running with this skill. So if you notice with every single one of them, none of them is starting from zero. Every skill you have some in some shape and form being from telecom industry. All you have to do is like how to incrementally bring that information about the space knowledge. So let's flip over to commercial side of things and see what other opportunities are there. If you are in product, business development, program management, sales, or customer success, this is where you see more interest, like telecom product manager to space connectivity product manager. You're translating technical end-to-end capability into tiered consumer or IoT data plans and SOS based emergency products for direct-to-device. 4 to 8 months you could learn these areas. Wholesale or a BD manager to space partnerships. Basically, you're structuring the MNO and satellite revenue shares, your distribution deals, spectrum leases, literally the same deal architecture as wholesale roaming, just with a satellite operator across the table sitting instead of another carrier. So in 3 to 6 months, honestly, this might be the single lowest friction commercial area which you can learn and be ready for that skill set. Network program manager to space mission manager. You are running multi-year deployment cycles. Now you have to adopt to milestone gated funding deals. And this is a big mental shift because there's unpatchable hardware. You cannot pick a hot fix or push it to a satellite that's already gone and launched. So 6 to 12 months, you should look at the space mission management solutions or pre-sales engineer to satellite sales engineer. This is where translating the satellite latency, coverage, capacity, reliability, realities to enterprise IoT solutions for customers. 3 to 6 months, you should be able to learn and map that skill. Customer success or operations to satellite operations and customer success. You're managing post-sale enterprise customers, but there will be different set of challenges. For example, degradation because of weather, satellite specific SLAs, etc. So 3 to 5 months, you should be able to learn this. So across engineering and commercial, you're looking at a realistic window of 3 to 6 months, 1 year maximum, depending on the role. So there's one persona which I have to call out specifically because it's the rarest, most valuable profile in this entire transition. Let's talk about it. Spectrum and regulatory. If you have personally managed telecom spectrum licensing and interference coordination, stop and pay attention because this is the highest leverage in this video. Look at the Venn diagram. What you will see is on one side you've got national terrestrial regulatory knowledge dealing with bodies like FCC, Ofcom, or any regulator in the country of globally. On the other side there's a ITU which coordinates the orbital slot connection. The overlap in the middle is at the silver, and that's the unicorn, and that's not an overhype. Very, very few professionals in the industry actually hold good knowledge of both terrestrial spectrum as well as international satellite coordination knowledge. If that's you understand it, you have most sought after profile and skill in the industry, which is in aggressive demand right now. And notice the transition timeline for the specific path is 3 to 6 months. So it's all about regulatory process navigation, knowing how to build coordination case, how to work with the regulator, how to define a filing. That skill is transferable if you have done it. You're not learning a new skill. So let's also be a little balanced. It's not completely free lunch. There are real genuine gaps we have to close. So let's look at exactly what you have to close. To be direct with you, because a video that only tells you all the good news, good things is not going to be useful to you. Look at the base of this pyramid. That's exactly you already have. Carrier grade operations, link budgets, core architecture, wholesale negotiation, 3GPP standards knowledge. That foundation is solid. But there are 3 generally things which there's a new domain sitting on top of that, and that is space, which is adding that element of it. And that doesn't get covered by the telecom area. So what are these areas? One is physics and environment, orbital mechanics, Doppler shift, compensation, thermal cycling, radiation hardened design principles. This is new physics which typically is not in the telecom area on the ground. Policy and law, international orbital slot treaties through the ITU, orbital debris management. There are strict export control regimes in countries we're working with. So there's a real compliance layer to this, which is not existing typically in terrestrial telecom. Process and hardware, the space system engineering life cycle, things like preliminary design review, critical design review, and probably the biggest culture shift. And the reason is because in telecom, if something breaks, you can still go and push a patch into the physical network, but in space, once it's launched, you cannot often, touch it again. So that changes everything, how rigorous you have testing the system and how you have verified before the launch. So it's a mindset that you have to walk away with. Don't try to become a space engineer overnight. Become a telecom expert who has intentionally closed these skill gaps. You're not starting a new career. You're doing a targeted, deliberate upskilling on a top of a career you already know. So what does it look like month on month? Let's take a look at that. Your actual transition plan broken into 4 phases. Phase 0 is orientation, where you spend 1 to 4 weeks looking and auditing your own skills against the 12% of example we talked about, or quickly, honestly figuring out which is the best area where you're good at. Assuming 3GPP release 17 in summaries and start reading the engineering blogs of your target companies. This phase is easy. You can start tonight. Second is phase 1, the foundations, which will take month 1 to 3. Complete a foundational satellite communication course. This will give you a foundational of the satellite technology, and you can look at a couple of professional space industry body courses on that. The phase 2 is a targeted depth. Phase 2 is targeted depth around month 1, 2, 3, 6 months. You can build one space specific portfolio artifact. This doesn't need to be like a huge thing. You can have a simplified Leo link budget calculator or one pager for your hypothetical direct to device product, and you can use a lot of generative AI tools for doing this. Something concrete you can show in an interview and start networking inside actual space communities. For example, you can look at creating a mission dashboard, a launch dashboard using Replit or some other tools, and show I understand how this works as a network operations center dashboard, for example. The phase 3 is about active transition. That will take around 6 to 9 months. Now you actually apply, but critically apply your learnings in the space industry. And that's when you look at the offers, you negotiate for structured onboarding support to space employers so that they expect you to invest in you in some bit of a training and knowledge as a transition. So now that you have built these skills, you still have to get past resume screening. So let's talk a bit about resume screening. So there are a few mistakes which I constantly see, and there are easy fixes which you can look at. One is like, how do you map it to what is needed by the hiring manager? Because hiring manager will not map your telecom skills to space industry skills. You have to help. So look at the use cases. Optimized RF coverage for 4000 LTE site somebody has done, for example, for 5G network. You have to really show them that I understand designing link budgets directly transferable to satellite to ground engineering. Like I understand antenna path gains, noise analysis, etc. Similarly, you can show about I understand working on NOC operation center, but I understand how it leads to a 24/7 network operations from a SLA management or satellite management point of view. So you're not investing anything net new. You're just kind of transitioning your skill into a extra third pillar of a space. So help out the hiring manager to see your domain expertise coming in telecom and how it's relevant to the space industry. Geography does matter when you look at the career opportunities because there are hubs globally. So for example, in US, Seattle and Redmond is the hub for constellation and cloud ground segment work. Starlink, Amazon Leo, they operate out of Seattle and Redmond. LA is good for launch and hardware or payload manufacturing. DC is good for policy, spectrum management, regulation, etc. In Europe, you have Paris, where a lot of work is happening, and for these European satellite manufacturing. Harwell and Oxfordshire in UK is another cluster for operators in this area. In Asia, Bangalore is fast picking up as centers for satellite IoT as well as NT and R&D. So the insight is very simple. Like, you have to understand where you have to look at in terms of the hub, where is the career opportunities, where the companies are expanding. So let's do one this final wrap before we wrap it up. And I want to just tell you, like, blindly don't follow. Understand the myth versus the reality. So the number one myth is that, hey, I need to have an aerospace engineering degree. You don't have to. You just need deep hardware and payload design roles. Look at NT and ground segment commercial teams. You can bring your telecom experience and map it to the space requirements. The second myth is, I have to take a massive pay cut. You don't have to. It's actually the opposite. There's a lot of demand and hiring happening for the roles which understands the network coordination. You would have read the news. SpaceX Starlink is now planning to launch their own network services, mobile phone services. So there's going to be growing demand in this area. Third myth is, I have to start all over it at the entry level. You don't have to. You have to pick where you have learned the art of telecom industry and augment on top of it, mapping to the space industry. So every one of these myths sounds reasonable on the surface, but every one is wrong unless you can go and look at your skills and how you can be relevant to the companies working in this space. What I want to leave you with, the telecom to space transition is one of the most structurally sound career moves available right now. The market is exploding, 31% CAGR. The skill overlap is very valuable here. You can just upgrade your own skills in the space industry and identify the focus areas and augment them. You are not starting all over again. You're just banking on your telecom experience and putting a third pillar to it. So choose your persona, chart your roadmap, make the orbital shift. If this video was useful, subscribe to my channel. I'm going to go deep dive into space and satellite industry from telecom professional point of view and also from a space point of view. There's a lot more coming, including deep dives. If you want to understand where space, telecom, and AI and robotics is heading, not just the headlines, subscribe to YouTube as well as my Instagram handle, and both goes by Nuggets by PC. So like, subscribe, and share. Thank you for watching.